Hello students, today we'll learn rotational dynamics. You see that these are the picture of rigid body. How will you define rigid body? A rigid body is a one whose geometric shape and size remains unchanged under the action of external force. So suppose if you see some external force over here, if it is acting on it, then there will be no change in its shape. What is the another characteristic of it? For such body, a distance between two particles of body remains constant. So if you see, suppose I have taken this particle and this particle. So the distance will remain unchanged even if you apply a force F1, F2, F3 or Fn. No material body is actually perfectly rigid, but many bodies can be considered to be rigid for a practice purpose. For example, a ball bearing made up of hardened steel is a good example of rigid body, or the irregular shape or stone. So here is a picture of this ball bearing. We can consider this as a perfectly rigid body. Let us learn more about the rigid body. Here we'll consider the same diagram where the force F1, F2, F3 are adding. So let us see here where the mass of a body is m1. Fx, summation of Fx is a sum of force in a x direction. And that is given by magx. Summation of Fy is a force in a y direction and its value is given by magy. You see the diagram, there is F1, F2, F3 all are acting on it and each force has its own direction, and if you resolve this vector, so it will be get resolved into two components. One is in a x direction and one will be in a y direction. Agx, A is acceleration, and if it is gx, that is acceleration at the center of the mass g in the x direction. Then agy is the acceleration of the center of mass in a y direction. So it's already shown here. A gx, it is here, and agy, it is along the y direction. Alpha is the angular acceleration of a rigid body with respect to the ground, and we can consider the g is a center of mass. So if you see the diagram here very well, it totally expresses how it can be act as a rigid body, where we have considered m as a mass of a body. The total force acting along the x-axis is given by the summation of Fx. Total force acting along the y-axis is given by summation of Fy. AGX is the acceleration of the center of a mass in the x direction, and AGY is the acceleration of a center of mass along the y axis. G is the center of mass, and alpha is the angular acceleration of a rigid body. Distinguish between center of mass and center of gravity. Most of the time we consider these two terms are same, but they are different. Center of mass is that point where the whole mass of an object is supposed to be concentrated, and center of gravity is at that point with which the whole body is attracted towards downward direction towards the earth surface due to the earth gravitational field. Now if you see the diagram, we can distinguish center of mass and center of gravity with the help of gravitational field. If there is a uniform gravitational field, so we found the center of mass and the center of gravity of a particular object is same. And if we applied a non-uniform gravitational field, then we found that the center of gravity and the center of mass will be different. So it again depends on the applied condition, whether the gravitational field is uniform or whether it is non-uniform. Center of mass and center of gravity can be distinguished with the help of applied condition of gravitational field. Center of mass of the symmetrical object. Let us consider some rigid object with uniform density where the center of mass is located at the centroid. See some diagrams here. These objects we have considered of a uniform density, and the green dots you can see in each diagram. For cylinder, for triangle, for a ring, for a square, and for rectangular. These points are nothing but the centroid point as well as the center of mass. Why? Because these objects have symmetry. Sometimes this center of mass cannot be fall anywhere on the surface of the object. Now if you consider just a ring, so the center of mass of the ring will be located exactly at the center of that ring, and where there is no surface of the ring exists. But if this is a circular sheet made up of the iron, steel or whatever, if it is a plain sheet, then the centroid can be exist on the surface of the object, and therefore we say that sometimes the center of mass does not fall anywhere on the object. Similar same thing, if it is just a square, the centroid will be exist exactly at the center of the square, is not fall on the anywhere on the object. Same thing for the rectangular. Now if there is a rigid body, then how to find out the center of mass of a rigid body? So most famous method is plumb line method. This is very much useful for an object which can be suspended freely about a point of rotation. Suppose you take a irregular shape of piece of cardboard paper and suspended it on a pin board. So we find that the pivoted cardboard will be pivoted cardboard can be hang freely around the pin under the gravity and it reaches the stable point. Once it reaches the stable point, we can draw a plumb line from the pin like this, which is acting in a downward direction. Now the pin is moved to the another location and will repeat the same procedure. Then we can find out the another plumb line. So we find a intersection of this two plumb line, and this point is nothing but the center of a rigid object. So plumb line method is very much useful to find the center of mass of a rigid object. Let us distinguish between circular motion and rotational motion. Circular motion is a special case of linear or translation motion in which a particle revolves a circular motion, that is along the circumference of the cell. Here the whole body performs a circular motion. It moves along the surface of circumference of the circle. Whereas in rotational motion, a particle of a rigid body performs a circular motion where a center of these circles lies on a straight line called the axis of rotation. Means a rigid body consists of a many nth number of particles, and each particle performs a circular motion about a axis, and this axis is nothing but the axis of rotation. In a circular motion, the axis of rotation and the center of mass does not change. In a rotational motion, the axis of rotation and center of mass could be changed. In a circular motion, this motion associated with a centripetal force. The centripetal force is required to perform a circular motion, whereas in rotational motion it is associated with a torque. So when a torque is applied to the body, the object starts performing a rotational motion. In a circular motion, the linear speed of a circulating body is always tangential to its circular path. You see the diagram. So the force or the vector which is acting towards the center, that is a centripetal force vector, and the velocity tangential to this circular path is a linear velocity of the particle, and this linear velocity vector and the centripetal force, they are perpendicular to each other. And in rotational motion, we found the linear speed of a particle of the rigid body moving in different circles at any instant are different. So here also each particle of each plane performs a circular motion about the axis of rotation with a perpendicular distance r, say r, from the axis of rotation. Let us start with our first chapter of 12th standard, rotational dynamic. We have already distinguished between the circular motion and rotational motion. Let us see main characteristics of circular motion. First is, it is an accelerated motion. Why it is called it as an accelerated motion? Because as the direction of velocity changes at every instant while performing a circular motion, it is called it as accelerated motion. And this is also known as a periodic motion. That is, during its motion, the particle repeats its path along the same trajectory, and therefore it is also known as a periodic motion. So there are two characteristics of this circular motion. One, that is a circular motion is an accelerated motion as well as a periodic motion.